Alright, so this is lesson 5-2. We're starting on page 99 of your workbook, and we are talking about unit rates today. So before we were talking about ratios, and it says a rate is a ratio of two measurements having different units. Okay? When a rate is simplified so that it has a denominator of 1, it is called a unit rate. And you should have heard about units, rates, and rates in 6th grade, so this should be somewhat review here. It says complete the Venn diagram by writing the phrases below in the correct position. So remember, on a Venn diagram, the overlap is where it's both rate and unit rate. So $24 for 3 pounds, that first one. That first one's just a rate because the second number is not a 1, the second number is a 3. Okay? Can be written as a fraction. Both of them can be written as a fraction, so that one would go in the middle ground. 15 students per teacher. Since it says per teacher, that means for one teacher, so that would be a unit rate. $10 per hour, so that's $10 for 1 hour. That would be a unit rate. And 18 red cars for 6 blue cars. That is a rate, but not a ratio. So notice it's cars to cars, it's red car, and then blue car, so they're a little bit different. And that second number is not a 1, so that would be a rate here. Okay, so hopefully you understand the difference between a rate and a unit rate. It says, find unit rates. A rate is a ratio of two quantities having different kinds of units. Suppose you text 60 characters in 30 seconds. This can be written as a rate. 60 characters over 30 seconds. Different kind of units, characters and seconds. When a rate is simplified so that it has a denominator of 1, it's called a unit rate. So notice on the left here, we took our 60 characters over 30 seconds, and what they really did is they took their two numbers and simplified them. Okay? To get 30 into 1, well, anything divided by itself is 1. So that's why I know I divide by 30. For the 60, the same thing. If I divide by 30 on the bottom, I have to divide by 30 on the top. So 60 divided by 30 is 2. So you're always, for a unit rate, you're always going to divide by whatever that bottom number is, because that's the only way to get a 1. Says to write a unit rate as a unit, or to write a rate as a unit rate, divide the numerator and the denominator of the rate by that bottom number. So example 1 says express each rate as a unit rate, round to the nearest tenth if necessary. And up at the top you can see it says or cents when talking about money. So for money you always go to 2 decimal places. So on the first one it says $11 for 4 boxes of cereal. So that'd be $11 over 4 boxes. Remember, we want to get it for 1 box. That's what it means for a unit rate. So I always divide by whatever that bottom number is. If I divide by it on the bottom, I have to do it on the top. So I know that's 1 box on the bottom. And this is one you'd probably want to use your calculator for. 11 divided by 4 gives me $2.75. So I would know it's $2.75 per box. When we say per today, with writing our unit rate, you can just use a slash like I did. On the next one, it's 400 miles on 14 gallons of gas. Okay? We always divide by the bottom number, so we divide by 14 on the bottom and the top. That gives me for 1 gallon, which is what we're talking about for a unit rate. We want how many miles for 1 gallon. And when we do that, when you round to the nearest tenth, it would be 28.6 miles. So that means it's 28.6 miles per gallon. And if you would like to leave it like this, you can, or 28.6 miles per gallon, like that. Either way means the exact same thing. Go ahead and do your 2 got it problems, and then we'll come back and go over those. Alright, so 1A says $18.50 for 5 pounds. So notice we put our $18.50 on the top, we put our 5 pounds on the bottom. We want to be able to get it to 1, so you always divide by that bottom number. So that would give me $3.70 per pound. Remember, when you are writing money, you cannot write it with 1 decimal place. It always has to have 2 decimal places, so make sure you add that 0 in. On 1B, it's 100 meters in 14 seconds. We divide by 14 so that it gets down to 1 second. That's the whole point of a unit rate, is that the bottom number becomes a 1. And when I divided 100 by 14, it was 7.14, some more numbers going on. So I looked at that 4 and I know it's 5 and above, give it a shove, and then 4 and below, that's when you would just keep it the same. So it's 7.1. In your workbook, it says the real world link, page 99. When sending text messages to a friend, Markeisha typed 90 characters in a little more than 60 seconds. If she typed at a constant rate, how many characters did she type each second? And notice in the question here, it tells us how they want us to write it. Characters for each second. So I know I want my 1 to be at the second. So that means the seconds have to go on the bottom. That means my characters have to go on the top. So we would plug in our numbers that we know. It said 90 characters. It said 60 seconds. We need that 60 seconds to be down to 1 second. So we divide by 60 on the top and the bottom. And you end up getting 1 second. And 90 divided by 60 is 1.5. So it's 1.5 characters per second would be your unit rate on that one. When you look at the next page within your workbook, it says determine if each situation in the table represents a unit rate. Write Y for yes and N for no. If no, write the situation as a unit rate. So you need to take your time and go through each one, read the situation, 60 pages, read in 40 minutes. It's either going to be a yes, that's a unit rate, or no, that's just a rate. If it's just a rate and you write a no, go ahead and change it to a unit rate. Okay? So take a second, fill in all of that table, and then we will go over. All right, the first one, 60 pages read in 40 minutes. You can kind of think of it as if you can see 2 numbers, it is not a unit rate. If you can see 2 numbers, I guess, and one of those numbers is not 1, then it is not a unit rate. So that was a no, and you can see up here I wrote that problem out, and I did divide by 40 on the top and the bottom to find that it was 1.5 or 1.5 pages per minute. The next one, 50 miles per gallon. There was no number there. That's for 1 gallon. That's a unit rate. $7 per movie ticket. Per movie ticket. That's what makes it the unit rate. The next one, 300 miles driven in 5 hours. No, that is not a unit rate. I had to change it to a unit rate, And you can see here I did 300 miles over 5 hours. Divide by 5 because that gets me the per hour I'm looking for, and that's 60 miles per hour. Same thing on the next one, $9 for 2 sandwiches right here. I have to divide by 2 because I want it for 1 sandwich. Notice the 1 is always on the in the denominator, never in the numerator. We want to say per one of something, for one of something, for each, for every, for one. Those are our unit rate words. Okay? So it would end up being $4.50 per sandwich. And the 5 pencils for each student, that's already as a unit rate. Then we have comparing unit rates. So you can compare unit rates once you solve them to see which one, a lot of times we use this in the store, which one's a better price. So example 2 says online music stores sell 15 songs for $12. Another online music store sells 10 songs for $9. Which online store has a lower cost per song? So we have, you always put your price is almost always on the top. If you weren't sure and you thought the 15 should go on the top because it came first, 15 songs for $12. If you read the question, it says, which one has a lower cost per song? So that means it's cost over songs. So $12 for 15 songs. And that would mean I divide by 15 to get for 1 song. And when we divide for 1 song, it would be 80 cents. Okay? Then, the second music store, when we look at it, they said it was $9 for 10 songs. Okay, we divide by 10 since we want the bottom to become a 1. So that's 1 song would end up being 90 cents. So then we have to compare them. We look at our 80 cents. We look at our 90 cents. And we see which one is better. And when you think about it, 80 cents is less than 90 cents. So the first store has the lower price. So the first store has the better price. Go ahead and look at your got it. It says a store sells 2 different sizes of the same brand of sunscreen, 8-ounce bottle for $5.76 and 12-ounce bottles for $8.88. Which size bottle is the better buy per ounce? So go ahead and take a second and solve to see which one is the better price. When we take a look at the work, we see that the first bottle was $5.76 for 8 ounces. That means when we find per ounce, it's 72 cents per ounce. On the second bottle, it was $8.88 for 12 ounces. So when we find the per ounce there, it's 74 cents per ounce. So when it says which bottle is the better buy per ounce, that would be the 8-ounce bottle. 8-ounce bottle would be, and if they want an explanation, you can say that it's because 72 cents is less than 74 cents. Since we're now comparing the per ounce price. Since they have the same bottom number for per ounce on each one, we can compare just the top numbers. Just like in a regular fraction, when they have the same denominators, we can compare the numerators. This happens a lot in real life, okay? When you're comparing brands. A lot of times they're going to be the same size, but you have a generic brand compared to a name brand. And you can figure out what the price per ounce is to find the difference. Sometimes it happens within the same brand and they give you two different sizes. And so you have a smaller size and a bigger size. We tend to think that the bigger size is always going to be the best value, but sometimes it doesn't end up being the best value, and they're just trying to market you to get the bigger one, and they end up, you're paying more per ounce. Okay? So, like, let's look at this one. It was 98 cents, and it's kind of hard to see right here, but it does say that it's 14.75 ounces. So we would have our 98 cents over 14.75 ounces. You would divide by 14.75 on the top and the bottom. And when you do that, what would we get? What would be our price per ounce? Remember, when you're thinking about this, you want to find what it would be in dollars. Okay? So go ahead and figure out what that would be for us. And I just realized that I accidentally wrote the wrong number. I said it correctly and wrote it wrong in case you were confused by that. That was a 5 there. Okay? And when you do that, you end up getting 0.0664468. But we're talking about money, so we need 2 decimal places, and on this, since it's 6 is the third digit, that means our second digit in the hundredths place is going to round up. So we're going to say it's 7 cents per ounce. On the other side, we know it's $2.12 for, and again, it's kind of hard to read it there, but it does say for 26.25 ounces. So we would divide both sides by, both the top and the bottom by that 26.25. And when I do that in my calculator, got to type it in real quick. I figured out what it is. You go ahead and figure out what it is per ounce. Make sure you are writing it as money. So go ahead and do that. And you should have gotten that this one was 8 cents per ounce. So it's not really that big of a difference. You're paying about 1 more cent. It's really about 1.5 cents since we had to round the left one so much up to the 7 cents. But that's one case where the bigger one's not really the better deal. And sometimes that happens, and you just need to be aware of that. There's another example. We're going to skip over some of these. In your workbook, it says fill in each circle with a less than, greater than, or equal to compare the unit rates. Then explain why you chose the sign that you did. So I'm going to give you a minute. Go ahead and decide whether it's a less than, a greater than, or an equal to, and then explain why. When you look at number 1, it was 10 books for $12, and make sure you're always putting money on the top. There might be a few chances where the money's going to be on the bottom, but I would say 99% of the time when you're doing problems, the money will always be on the top because we're always trying to find price per item. Okay, so the price always goes on the top, the item on the bottom. So $12 for 10 books, that would be $1.20 per book, or $18.75 for 15 books, that would end up being $1.25 per book. So $1.20 per book is less than $1.25 per book. Number 2, it's $4.20 for 12 cans, and it's $6 for 20 cans. So that ends up being, on the first one, 35 cents per can, on the second one, 30 cents per can. So obviously 35 is greater than 30 cents. Once you know the unit rate, you can use it to solve problems involving any amount. So it says, a typical bottlenose dolphin will take about 34 breaths in 4 hours. So that's the first thing that you would need to solve. Then it says, how many breaths will the bottlenose dolphin take in 7 hours? So when we're looking at this, the first thing you want to do is use the rate they gave us. They told us that this many breaths goes with this many hours. So those should be the two numbers I use together. Remember, we want to find our unit rate first. So that means I want to get this bottom number to be a 1. So to do that, I have to divide it by itself. So that gives me my 1 hour on the bottom. And 34 divided by 4 would be 8.5 breaths. So 8.5 breaths per hour. Now, the second part of the question asks for 7 hours. Well, if I want to make this 1 hour into 7 hours, I multiply by 7. So times 7, because whatever I do to the bottom, I have to do to the top, tells me that in 7 hours, I would end up with 59.5 breaths. 59.5 breaths in 7 hours. That's how many a bottlenose dolphin takes in 7 hours. So the goal is always take the rate that they gave you and find your unit rate, because once you have your unit rate, you can always get whatever number they're asking for by multiplying it by 1. That also means whatever number they're asking for here, the hours have to start on the bottom then, so that we turn that into the unit rate, and then we multiply to make it into that 7 hours. Okay? You do have a got it problem, but I want to show one more example before you get there. So it says, and this is from the guided practice number 8 on page 191, in case you want to look at that in your text. But it says, Aisha drove 170 miles in 2.5 hours at this same rate. How far will she drive in 4 hours? So the first thing is we have to set up our rate. And it told you what you want on the bottom here, since we want it for 4 at the end. We know we have to have hours on the bottom. But if you think about it, miles per hour, hours per mile, obviously we want the miles per hour. You've probably heard that multiple times before. So we have our 170 over 4 hours. What do I have to do in order to get to my unit rate? And I just realized we have the wrong number here. Make sure you're not being silly like me and underlining certain parts and then putting them in the wrong spots. It should be those two numbers together that we're starting with. So now, what do we need to do to start this problem? So we should be dividing by 2.5 so that we get 1 hour on the bottom. And when we do that, you end up getting, let me see, I got to type this in. 170 divided by 2.5, we get 68. So 68 miles in 1 hour. But that's not what they asked us for. They wanted for 4 hours. So what do we have to do now? Yeah, we have to multiply by 4. So 4 hours we end up getting 272 miles in 4 hours. Now we're going to go back to that got it problem. So it says a bakery can make 195 donuts in 3 hours. At this rate, how many donuts can the bakery make in 8 hours? So we're going to pause the video and you are going to try solving all the way through on that. Okay, so we started off with 195 donuts in 3 hours. So that was our starting rate. We had to turn it to a unit rate. In order to do that, I need the bottom number to be a 1. So we had to divide by 3 because 3 divided by 3 gives me 1. So my unit rate was 65 donuts per hour. Once you have a unit rate, you can easily multiply the bottom number. For 1 hour, it's 65. So for 8 hours, I would multiply that 65 times 8 and end up with my answer of 520 donuts in 8 hours. Let me know if you have any questions about finding the unit rate, or once you have the unit rate, how to find it for another unit of time or whatever on the bottom number.